Hello, and thank you for listening to the Chiropractic Research podcast series. My name is Dr. Dean Smith. I'm a clinical faculty member in the Department of Kinesiology and Health at Miami University, and I'm also a chiropractor in Eaton, Ohio. My research interests relate to understanding how chiropractic affects motor control and human performance. Thanks so much to all of the listeners out there. I wanted to share a recent review on iTunes from Dr. Zach Jipp. He says, I absolutely love Dr. Smith's podcasts. He brings the best of the best in the chiropractic profession to share current research knowledge with his listeners. His podcasts are engaging and informative, and I always end them being more knowledgeable than when I started. Great leader for the profession. Well, thank you so much, Dr. Jipp, for those kind words. If you like the podcast, please leave a 5-star review on iTunes so we can attract even more chiropractors to listen to the best in chiropractic research. Also, please consider making a contribution to chiropractic science to keep those podcasts coming. You can do so on our website at chiropracticscience.com by way of the contribution page, or simply purchase the Chiropractic Science Slides presentation package, which are evidence-based patient education slides for your practice. We are also on social media, including Facebook and Instagram. Connect with us there to stay up to date on all of the current happenings and learn about the latest podcast episodes when they're posted. Okay, on to the podcast. My goals for producing these chiropractic research interviews are to get the word out about chiropractic research from the experts that are actually doing the research. And secondly, to encourage collaboration of researchers. And lastly, to motivate and assist practitioners and students alike to pursue research careers in chiropractic science. Well, let's get to the interview with Dr. Cindy Long. Dr. Cynthia Long is professor and director of research at Palmer College of Chiropractic in Davenport, Iowa, and director of the Office of Data Management and Biostatistics, or ODM, at Palmer Center of Chiropractic Research, or PCCR. She holds an MS degree in statistics from Iowa State University and a PhD in biostatistics from the University of Iowa. Dr. Long joined the faculty of the PCCR at its inception in 1995 and contributed to developing PCCR's research infrastructure, in particular creating the ODM to support the research design, data management, and data analysis needs of PCCR research investigators. Since 2000, she has directed the ODM staff as data coordinating centers for 15 on-site, off-site, and multi-site federally funded clinical trials of chiropractic care. Dr. Long is the principal investigator of expanding evidence-based clinical practice and research across the Palmer College of Chiropractic, a grant awarded by the National Center of Complementary and Integrative Health of the National Institutes of Health. She is also the director of Palmer's MS in clinical research, where she teaches 10 credit hours of biostatistics. She is on the editorial boards of JMPT and JCCA and just completed a 3-year term as an elected member of the American Statistical Association Board of Directors. Dr. Long, it's a pleasure to have you on the Chiropractic Science podcast.
Well, thank you very much. I'm happy to be here.
Yeah, I've been looking forward to this interview for some time because I know statistical questions are always on the minds of practitioners who read articles, and there's always questions to be had about them. So really looking forward to this. Can you tell us about how you became interested in statistics and then biostatistics?
Sure. So when I was in college, like many people that go to college, I wasn't really sure what I wanted to do with my life or what kind of career I wanted, but I was very good in math, so I kept taking math classes and ultimately declared a math major. But then I noticed that we had a really new. I went to Winona State University in southeastern Minnesota, and they had a fairly new program that was a bachelor's degree in statistics, and I didn't know much about statistics. But I noticed that I didn't have to take very many more classes because I had so many of those math classes to double major in math and statistics. And so I decided to do that. Even after taking that program, I knew not much about statistics, or really, I knew I didn't think I wanted to teach high school math, and I was thinking that was probably the only career choice there. So I finished all my coursework, and then with this program, you had to do an internship. And so Winona is very close to Rochester, Minnesota, so I was able to get an internship at the Mayo Clinic in the Department of Biostatistics. And so I did an internship for 6 months, and very clearly, very soon after getting there, I realized, okay, statistics is great. And of course, biostatistics is just that related to healthcare research, and that's what I was doing at the Mayo Clinic. I was working as a data analyst under the direction of statisticians or biostatisticians. And I think, they asked me, they hired me as a data analyst as soon as I finished with my internship. And so clearly, it was just a very exciting profession, and I was learning things every day. And it became very clear that, I guess one thing I will notice that I think is sort of interesting, because no one ever knew what statistics was, and I didn't even, until I did my internship, really know much about statistics. Very different today, where most people have to take statistics. And I don't know if you've seen this, but the number one job in Comcast.com survey or annual thing last week just was statistics. Which
wow,
is incredible. And in fact, there have even been articles about statistics being the sexiest profession now. But I can tell you that when I started in statistics, there was nothing like that out there, and most of us didn't even really know what statisticians did. But I think people have a better understanding now.
Perfect. So was it the internship at the Mayo Clinic that got you interested in research, and then subsequently completing your PhD?
Right, because, there are lots of different areas that people, and in particular things like big data. You hear big data all the time, where companies have so much data now, they're collecting data online, and people go in and they sort of data mine and try to figure out, okay, what customers like based on what they click on and such. There are lots of census. They hire a lot of statisticians, but most statisticians work in research environments, and in particular, if you're involved in healthcare, you are in a research environment. That's what you're doing as a statistician. And so, really, everything I've ever worked in, other than teaching, has been in a research environment. And I realized very quickly at the Mayo Clinic that I learned so much there and got a whole bunch of tools. But if you really want to be employed as a statistician, especially back then, now some undergraduate programs might prepare you a little better for at least sort of doing data analysis. But you really have to have a graduate degree. And so that, and almost immediately my mentors that I worked with started pushing me toward looking at different programs that they were familiar with, and and that's how I ended up at Iowa State University, which at the time was one of the top, I think it's still pretty high, but one of the top statistics programs in the country. And it was a great 2 years. Really all of graduate school in a master's program is really foundational, and so it's not very different if you do statistics or biostatistics. You get that same foundation. But I didn't stay there because if I was going to do the PhD, and I wanted some option of teaching. A lot of master's level statisticians go out into the field and do wonderful, but you can't really teach beyond the community college, and I wanted the option at least of teaching. So I went to the University of Iowa School of Public Health, or College of Public Health, and did my PhD there in biostatistics, and that was just for me the best move, because all of my coursework was directed at really healthcare related research, and it also gave me a broad understanding of epidemiology, and that fits in really importantly with biostatistics. So that's and I've only been involved in research environments.
Fantastic. So how did you get from there to being involved in the chiropractic profession?
Well, I would have never imagined that would have happened. I did not know when I was finishing my PhD. I had not met a chiropractor. I didn't know what chiropractic was or anything about it. But that is, I was finishing the summer, the spring, I guess, of 1995, and really was looking to stay in the area for personal reasons, at least initially. And so I saw a job ad for the position at the Palmer Center for Chiropractic Research. I don't even think, actually, it was probably Palmer College of Chiropractic. And I asked my mentors about what they thought, because certainly we didn't know of any research in chiropractic. And and they sort of said, well, go ahead and apply and see what's there. And so there really was, there were just a handful of faculty. Cheryl Hawk was here. She was an early colleague of mine. Bill Meeker was the director, so he came on the same time that I did into the Davenport campus. The person who's our chancellor now actually was a junior faculty member in research at that time, Dr. Denny Marchiori, and so they were. I mean, nobody. I think I'm still the only statistician on the faculty, and certainly in any kind of leadership position at a chiropractic college in the United States. Sort of amazing that they had that foresight that it would be good to bring a statistician on board. And I was a little skeptical. There hadn't been much research, and I didn't know. But my mentor said, after your PhD, you kind of have a free year. So if it's not looking good after a year, get out. But you might have the opportunity to build things the right way if you're on the ground floor. And so I sort of anticipated probably looking for another position a year later, but here I am, I think it's about 22 years later, and I'm still at the center, so it has gone well.
Yeah, well, thanks for being there, and thanks for all of your amazing contributions. What's a typical day in your life like?
Well, so I for 6 years now, I've also been the director of research here, which is really an administrative piece. And I won't talk about that at all, because, any of us that do any administration know that that's sort of the same thing all over the place. But most of my day, well, it's varied, but most of the day I'm doing something related to our research projects. And the life of a research project is really long, especially the clinical research. I have supported the basic science research program here, the biomechanics sort of preclinical research program, and in particular, what I've really helped grow and have been very involved with is all the clinical research, in particular our clinical trials. And I think you mentioned in your introduction that I founded and continue to direct the Office of Data Management and Biostatistics, where I have I have data managers, programmers, and master's level biostatisticians that work for me, varying depending on how many projects we have. And so we handle all the data for all projects in terms of data collection and data cleaning, and getting the data sets ready for analysis, and then analyzing the data. So, but really it depends. One day I probably look at an average of 5 to 7 aspects of projects every single day, which is one exciting thing about being a statistician, is you get you get a lot of variety in the kinds of things that you're doing, which is very fun. Being a good multitasker helps for me to be able to keep up with all of this. But so right now we're not writing any grant proposals, looking for grant funding, but we just spent all of February and part of March putting in a very big grant. And so during that period of time, I was very concentrated on different aspects of writing that grant, as well as many of my colleagues, and we're collaborating outside of here, so all the collaborators. And so when we're writing a big grant, that's pretty much all we're doing. But there's always other, then you get the funding, and then you have to get the protocol together and start meeting weekly, and then you implement the study. And in clinical studies in particular, I mean, I can't think of one that has taken less than a year and a half, because you have to screen participants for eligibility, and then there's typically a treatment period, and then even long-term follow-up. And so that's happening. That just continues to happen. And I'm always working on data integrity and making sure and oversight and monitoring of all of those data related activities. And then of course the fun part is when you close a study and you get the data sets, and you get to start analyzing the data sets. And that's where I think the ODM has sort of, everyone else sort of just waits until we analyze the data. And that's the real fun part. And then we work with the investigators to present the data, and then we decide sort of, okay, where's the primary publication going to go, and we start writing the article. So that can be 5 to 7 years probably, that whole process. And so for however many projects we're going, I'm doing a piece of that, several pieces of different projects pretty much daily. And that's, I think, for me, what makes it fun. I also work with with students. We have research fellows here, so I do a lot of mentoring with them, and with junior faculty, and with some of our professional staff who are doing small research projects of their own. And so mentoring is a really, for me anyway, a really fun part of my day as well.
That's really terrific stuff. And I can attest to the fact that you're a great multitasker, seeing you at DC 2017, and you were working on some manuscripts at that point, and that must have been a really busy time.
Well, it always is, because, stuff doesn't stop just because you go to a conference, right? And
right.
You get phone calls, or you're working on updating something that's going to get presented, or, there's always something. But that's all right. I do take one vacation a year where I disconnect.
Good.
And I say, everyone else is taking care of it. Here's my, one person has my emergency contact information, and that's it, because you do need a little time off. But I work with a great team of people here, and I think that's something that we all really need to remember, because you only see sort of the top people get the accolades, but you cannot, in particular clinical research, but really any research these days is a team science. And if you don't have a team, that's, I come on as a co-investigator, or just sort of the whole kind of project idea and all of that. But then I'm very much, working on the monitoring the data integrity and doing the data analysis, and that's sort of my role. But we have, we have a clinician, and we have other data related people, and we have project managers, and we have the PI who manages the whole project, as well as our collaborators, and you really need all of that to do good science.
Absolutely.
We're very fortunate to have attracted a lot of very good people here. I have to say that.
Yeah, and
I've hired a lot of them, so that's a good thing too.
I was really fortunate to be involved in one of the projects, so I got to see firsthand how everything smoothly worked together. That was pretty amazing.
Yes, so I had known your name for so long, but I don't think we'd met in person until DC 2017. So that was really fun.
Yeah, that was great. Now, you've been an author on a lot of excellent peer-reviewed publications from some of the best journals in the field. During this interview, I'd like to talk about your experience, not only in the chiropractic profession, but explore the statistical issues that both scientists and practitioners in particular face when preparing and reading research. So let's just go ahead and dive into that. And the first question that I have for you is, what is a statistician and what a statistician is not?
I'm very glad that you asked that, because when I first was studying statistics, and people would say, "Oh, what are you studying?" or "What are you? What is your career?" And I would say statistician, and I would get this look on a person's face. This is a while ago. It doesn't happen very often anymore, but they'd always say, "Oh, I took statistics once. It was the worst class I ever had." Which then how do you start having a conversation? I typically would say, "Well, you didn't have me for an instructor," because statistics is one of the funnest things to teach, and in particular if it's just sort of a general statistics class. And there has been I hope your listeners have had better experiences than that, because there's been for at least 15 years, almost 20 years, a revolution of change in teaching, but somehow there still seems to be those professors out there that rather than using data and telling stories and making it really interesting, they put formulas on the board, and that we just don't need that in this day and age. And that is not what statistics is, formulas and math and such. But as a statistician, I think I have told you this before, is my colleagues know that they should never introduce me like this, and they only do if they want to sort of prod me and give me a hard time, is that a statistician is a data cruncher. And that could not be further from the truth. I mean, I really shun at that description. And I would say that maybe an accountant is a data cruncher, but maybe there are other data crunchers out there. But certainly a statistician is not a data cruncher. I mean, anyone can crunch data these days. You just get on the internet or get on a statistical program and put some data in, and you can do whatever you want. But the statistician is the one that has the knowledge and should really be involved in all aspects of the research project. We'll talk about that a little more as we go, I think in the next couple of questions. But what a statistician is not is really important too, because a lot of people think, oh, the statistician does everything related to data. So, they're going to collect the data, or they're going to get the data, they're going to clean the data. And if you have a really small shop, certainly when I first came here, I did all of those things because we didn't have an Office of Management and Biostatistics yet. We didn't have much research either, so I could actually do it. But, everybody has their expertise, and the biostatistician, and primarily I might not have had that expertise except for I worked as a data analyst for 3 years at the Mayo Clinic. And so I did a lot of data cleaning and programming and putting data sets together and everything. So I did have that skill set. But as soon as I could build my Office of Data Management and Biostatistics, I brought other people in and gave them that skill set, because you need someone that is completely that is their expertise. And luckily, my data core manager, who's been with me for I think 18 or 19 years now. And he came in not really knowing anything, but having a huge aptitude, and I taught him everything I knew, and then he went and got a master's of in IT management, and he handles everything data related. I mean, I still work with him very closely, but he's the one that is the expert, and that you really need people who are experts. Statisticians are not necessarily data managers, and a lot of statisticians haven't really ever, if they didn't work like I did before I went to graduate school, they don't even have that skill set. So that's definitely something a statistician is not. And I would like to say that, statisticians aren't the ones, although they often are, but what we hate is that we're the person that, someone knocks on your door at the 9th hour saying, I have a grant due tomorrow, and can you do a sample size calculation for me? And certainly we do sample size calculations, but it should be part of the process and not at the 9th hour. And I've had not many, because I've been able to sort of dictate the rules that I work under here and how people can interact with me. But a lot of statisticians, especially if they're in sort of big universities and sort of manned, statistical consulting centers, will tell you that that's 40% of their of their job, and then another 30% is people saying, "Oh, I collected my data. Can you analyze it for me?" Well, if the study hasn't been done well, and the data hasn't been collected well, or the right data haven't been collected, statisticians, we're not magicians. We can't make your study. We can't fix your study if you didn't do it correctly, right?
Right.
And those are important things for people to understand.
Wow. So let's dive just a little deeper in that, the statistician's role, and maybe we can start out with, so is it a good idea then to get advice from the biostatistician before the research begins? And if not, then how should a biostatistician come on to the project?
Right. Well, one thing that we're fortunate here, because we have at least one biostatistician always, as part of the research center, is that, we should be involved from day one. And that is essentially what happens most of the time at the center. At the college, I do some consulting for the college if I have time, or if one of my ODM members has time, but we really don't, we're pretty small and we do a lot of studies here, so we don't have a lot of time to just to support other projects. So, basically, what I like best is if the PI or the investigative team, as they're thinking about what are their research questions going to be, that they stop in and just chat with me a little bit. Especially now, I have a much better knowledge about the kind of research we're doing, so I have a lot of insight. But even when I was first starting here, that was, and I, was so fortunate to have Cheryl Hawk, whom was doing the majority of the research that I was involved with. I kind of built a lot of the ODM services around her projects. And, I was involved from day one with her, and that was great. And as more faculty came on, at least once I would have one of them come in at the 9th hour and say, I have a grant due tomorrow, can you do a sample size paragraph for me? And very quickly we would learn that doesn't work very well. We try to get them out the door, but the next time they would come and talk to me, and especially one colleague that I worked with very closely. I mean, he talked to me before he talked to anybody else, and would start talking about what his specific aims were, and the research objective, what the research questions should be. And really, what I'm there is, I trust the scientists that they know what's important, but I can help them say, how can we then turn that into something, a hypothesis that we can test statistically, right? How can we, what do we need to measure, and how can we compare or groups or whatever the study design might be, and quantify, and what kind of methods, statistical methods, might be most relevant. And so, and then as I was talking a little bit earlier about my typical day, well, the statistician is involved in all aspects. The basic science, not as much with the data collection, although we have to, create the data sets. Anything clinical, really, you can't, to have good research, the clinical team cannot be looking at the data they're collecting. And we often now do a lot of patient self-report via web form. So, it's coming directly to the ODM team, and they're the ones cleaning it and querying if there's issues, etc. And you really can't be, you might bias your outcome if you're looking at the data and doing sort of interim looks. I don't even, I'm blinded to most everything as well. So it's really just the data managers and the programmers that are dealing with it at that time. And then, but in the clinical studies, as I mentioned previously, we monitor, we have weekly meetings on every clinical project we have with the whole investigative team, our collaborators off-site and people here, the key people, and we monitor everything about data collection and about accrual and all of that, and make changes. And then, of course, when the study closes down, I make requests for the data sets that we need for, usually there's multiple papers, and make sure that data has high integrity. And then we've been writing the data analysis plan. Usually the master's level biostatistician and I have put together a very careful, much longer than you would see in the actual resulting paper, about how we're going to analyze the data, what happens if if our assumptions are not correct, etc. And then some biostatisticians might not be as involved. It depends that, you usually have this agreement before you get involved with the study. And a lot of chiropractic colleges end up contracting out to a local, either a local statistical consulting center or a university. They'll contract out some of the statistics, and the best of them get them involved all the way through here. And you make an agreement whether you're going to be a co-author or not. And I'm always a co-author on anything that I've been involved with as a co-investigator. And so I certainly write all of the statistical methods. I help write all of the methods because I've done a lot of that. And I usually write, and this is with my teams here. This might not be everywhere, but I typically write the first draft of the results from a statistical perspective, and then we get everybody involved to make sure that it's, reading the way it should. And so that's sort of, in my mind, that is perfection, because then I've had a voice in everything, and I don't get those data sets. I still do. I still get some of those that didn't come to me early enough, but not many of them where I have to tell an investigator that, I'm not sure how we can answer this question with what you have here. And, because I can do some methods here, but I don't think we're going to be able to answer your question. And that's what we, by having a statistician or biostatistician involved all the way through, you can analyze and answer your important questions. It's a big financial finances, both internal, because we have support from our college, as well as our grants. It's the taxpayers. So if we have United States citizens listening here, most of our funding comes from the U.S. government. And so we owe it to taxpayers, and we owe it to the college to be the most efficient and to be asking, to be collecting the data such that we can answer those questions and make the most of that data, right? And I think a biostatistician is the one person on a team that can really try to make sure that happens.
Yeah,
but it takes the whole team.
That's really terrific.
It takes the whole team.
Yeah, very methodical, very clean. That's just amazing.
And, things will always come up. I got to tell you, you think you've dotted every I, you've crossed every T, and then something will come up. You're like, how did that get by us? But because we control every little aspect, we can usually figure it out, get it taken care of. Make sure that there was no bias introduced to the data or whatever the case may be. I mean, I'm always amazed that no matter how good you are, something comes up. But the closer you are to it and the better methods you have, that doesn't get in the way of your data integrity in the end. Let's hope anyway. It doesn't. It hasn't yet here.
Sure. That's great. Well, before we get into many of the statistical terms that chiropractors and others might want to know about, can we talk about the difference between descriptive and inferential statistics?
Yeah, that's a great place to start, because we hear these terms batted around, and maybe we think we know what it is, but we're not sure. So in the majority, certainly all of the research I'm involved in, the majority of research, clinically related, which is really where I'm focusing today, we want to make conclusions or know something about a target population in general. And usually for us, it's a patient population, right? And so we take a sample. All of our studies involve samples from that target population. We hope, there are a lot of things that don't have anything to do with statistics, but I bring them up all the time, is, all the things you want to do about choosing your sample so that it's representative of your population. And so that's really where descriptive and inferential kind of derive from. Descriptive statistics are just describing and summarizing the data from your sample. And so for a clinical research study, we'll always have that table 1 that will have all of the sort of demographic and clinical information about the patients, which is really important for clinicians reading the literature, because you need to say, are these patients like mine? Is this even relevant to me in my practice, right? And that's usually table 1 in a research article. And those are just descriptive statistics. They're typically descriptive statistics to let you know, what do these patients look like. Inferential statistics is the step where we say, okay, we have the sample data, but we really want to make inference about our target population. Because, there are things like case studies and case series that are purely descriptive. And you can say, this is what happened with this patient under this particular care, and that might be important to generate future research questions, but you're not going to ever be able to make inference about a target population from that, right? But when we do studies where we have samples of participants that we enroll in our studies, and usually, most of the studies we do here in clinical research are clinical trials where we're actually bringing patients in, often with neck or back pain, pain-related conditions are mostly what we work with in the clinical studies, although our basic science and biomechanics look at a lot of mechanistic studies. How does this work? We are really looking at outcomes typically in the clinical studies, and I think that that's primarily what chiropractors in the field are going to read too, at least in terms of how it might impact their practice. And so that's where you really need to look at the inferential statistics. That's where we see things. We'll be talking a little bit later. You will see p-values or confidence intervals, and that is where we actually test the statistical hypotheses that we make, and then we try to, we use that then to say, okay, this is what, we have our sample information, this is what we can say about what that means in the bigger target population. So descriptive is just describing your samples. Inferential is trying to really answer the research question you have about the patient population in general.
Excellent. Well, let's get into the top 9 or 10 statistical terms, depending on how we count these, for folks that want to know more about statistics. So can we begin with effect size?
Right. Effect size, I think that all of us clinicians, maybe even more than anybody, the first thing we're going to look at when we look at a paper is, how much did those patients in that study, how much did they change on maybe, the kinds of outcome measures we use in our pain-related studies would be on the pain intensity, the daily pain intensity, or the worst pain intensity over the last 24 hours, or on functional disabilities such as using a Roland-Morris or an Oswestry coins or a neck disability index. How much did they improve? You're going to anticipate that they're improving if they're coming in with the condition you're trying to treat. And that is essentially what the effect size is, in addition to what did they look like relative to the other group. If you have a simple study where you have one set of patients in your study that are undergoing just usual medical care for their pain-related issue, and then you have another group that had usual medical care, but they also get to have chiropractic care, and that is actually a design we're just writing a paper on right now. So it's one I'm super familiar with at the moment, and so you, in addition to saying how much did the patients improve in each group, you also want to say, well, how much difference were there in the improvements between groups? And when you just sort of, it might be means or percent of responders, those could be the kind of measures you're using, and you're just looking at the general measure, and the effect size is just a quick look at whether they're different or not, or just how much they changed. And the key thing here is that when we collect data on samples, there's all kinds of inherent variability. You don't get the same response from everyone, or we wouldn't need statistics or statisticians, right? And so as we'll move through some of these questions you have for me, we'll start talking about, well, how do we account for the variability? How do we account for the sample size? But effect size is just that straight first look. How good did they do, and how good did they do relative to the control group?
Okay, perfect. Well, let's talk about some other statistics clinically applied, and so maybe the first couple are fairly straightforward, but these would be means and standard deviations.
Right, and in a lot of clinical studies, we'll talk about a couple other types of measures, clinical statistics, and I should mention here, I should have mentioned this before, but I didn't. So statistics, sometimes there's misnomers because there's several different terms. So there is statistics in the bigger sense, which is the science of learning from data. I'm a statistician, I'm a scientist, and my field learns from data. Then there's the term statistics that is very specific, and it's what we call the summaries that we do from those sample, and in the inferential, but from our samples. And so means and standard deviations are things that we all see all over the place. And in particular, a lot of chiropractic studies were looking at things like pain intensity, quality, bothersomeness, functional disabilities, quality of life. We're looking at measures that we do get means and standard deviations for. And so the mean, I think everybody has a really good idea what a mean is. It's just an arithmetic average. You've got 5 people in the room, you ask them their age, you add up the ages, and you divide by 5. That is all a mean is. When we call it a mean instead of an average is because it's a statistic that we're going to use to analyze our data. First we describe it, and then we'll use it to analyze the data and do inferential statistics. Now, standard deviations, I'm guessing, are less well known, and whenever we're describing samples and then making inference about populations in those descriptive and inferential statistical states, we've got to also have a measure of variability. How much spread is there in the data? And a standard deviation, whenever you're reporting a mean, you should also see a standard deviation, because the mean's just sort of the effect size. It's just that center. But you might have data spread a whole lot, or you might have data that's very, very tight and very close to the mean, and that's important if you're going to try to find if there's signal in the noise. I think a lot of people think of statistics like that. Is it just all noise and there's just a center, or is there really a signal and it's not all noise? And so the standard deviation, I like to think it's not exactly this, but it's pretty close to this, and it's the average distance of the data from the mean. So if it's a real small, and it always will depend on the units of measurement, of course, but if it's very small relative to the mean, then it means the data are pretty tight and you don't have a lot of variability. If it's really big relative to the mean, then it means you're spread all over the place. And that will be very important when we get to thinking about inferential statistics.
That's great. Yeah, I like thinking about it, about spread as well. I think that's a good way to describe it. How about risk ratios, odds ratios, and relative risk?
Yeah, those are great. Risk differences is another one that we should add in there. And so risk in general is one type of clinical effect. It is typically described as the chance of having a successful outcome. I think that's the most generic and reasonable way to think about risk. When you have study designs, and I will say that you will see more and more of this in the chiropractic literature. In a lot of the clinical literature, they really use risks to compare between groups, whether it would be depending on the type of study it is, but might dictate it a little bit, but that is where you'll see a lot of it. We've had a lot smaller studies. These are usually bigger studies, but a lot of things, if you're looking at risks of drugs in particular, or outcomes from different drug treatments, you will see these risks in the results section of the clinical article. And you're seeing many more chiropractic clinical studies that also have these. So if you're talking about risk, you're talking about within each group, just like we talked about means, within each group, calculating the risk, or maybe risk isn't the best word there, but, sort of the chance of a successful outcome. And then you have to say, well, how do I compare between groups? Again, if you have one group that has usual medical care alone for their condition, and the other group has usual medical care, but they also have chiropractic care during their course of treatment, and you really want to compare the outcomes. Did the group with chiropractic care do better, and how much better than the group that had just usual medical care? That's usually what our research question of interest is, right? And so we have several different, we have odds ratios, we have relative risks, and we have risk differences. So let's start with the odds ratio, or a risk ratio, odds ratios and relative risks. Risk ratios is just a ratio of risks. And sometimes we have relative risks, sometimes we have odds ratios, and it depends on the study design. If we have a study design that's sort of cross-sectional in nature, meaning we take data at one time, so we don't necessarily know the cause and effect, but we take data at one time and we want to know if there's association between maybe a risk factor that we look back on, maybe age or sex or some other kind of risk factor, and the outcome of interest, where the outcome is either good or not. Then we can we would do an odds ratio as the estimate of the risk, because we would look at that odds ratio. It would be the ratio of odds, the odds of having a good success in one level of the variable we're interested in. Perhaps it's age, and it's young and old, and we'll estimate the risk or the odds of having a good outcome in the young group, and we'll estimate the odds of having a good outcome in the older group, and then we'll make a ratio of that. And if the ratio is 1, it means that the risk is the same. The chance of getting a successful outcome is the same. If it's bigger than 1, then it means the top group, the group that is in the numerator or the top of the ratio, has a better chance of a successful outcome. If it's less than 1, then it means the group on the bottom in the denominator, or in the bottom of the ratio, has a better outcome. Relative risks we interpret those the same way, but relative risks mean that we're looking forward. And so in clinical trials, you'll often see relative risk used because similar to other study designs that I've mentioned here, you have a group that you assign to usual medical care alone. You have a group that you have participants or patients that you assign to usual medical care plus chiropractic care. You get their outcome, and you decide if it's a good response to treatment or not. And then you make a relative risk. You put typically we put the group that we're really interested in on top. So we would put the risk going forward of having, or the chance of having a good outcome in the group that has chiropractic care added to their usual medical care. And on the bottom, we would put usual medical care alone. And so if it was 1, it would mean that they had exactly the same outcome. If it's greater than 1, then that's in favor of the chiropractic plus, or the usual medical care plus chiropractic care. If it's less than 1, then it's in favor of usual medical care alone. We also see risk differences also, which is just taking, and this is what means too. If you are looking at differences relative, or rather than risk ratios, 0 is what means there's no effect. So if you have a risk in usual medical care and you have an estimate of a risk in usual medical care, you have an estimate of a risk in usual medical care plus a chiropractic care component. And if the difference of their outcomes, whether of those risks of the outcomes or the chance of successful outcome is 0, then there's no difference. And that's a measure you'll see often. Same with means. I didn't mention this earlier, but when you're looking at means and you want to know is the mean pain intensity, improvement in pain intensity, here it is in the usual medical care group, here's in the usual medical care plus chiropractic care group. And if those differences are 0, then they're the same. So
Great.
Risk ratios and then differences, anytime you're analyzing a ratio, you're trying to look at around 1 because 1 would mean no difference. And if you're looking at it with respect to means or any kind of differences, mean differences or risk differences, you're looking at around 0. And that's an important thing, I think, for readers of articles to remember. The measures I've talked about so far are actually all effect sizes. I haven't said anything about variability, right? I'm just talking about clinical statistics, and these would be the effect sizes.
Yeah, this is really great discussion, and I appreciate you using chiropractic examples too. How about number needed to treat? This is something that I've seen a lot more recently in the last 5 to 10 years especially.
Yeah, you're right. You didn't see it in literature at all before then. I was actually looking at an article from one of our colleagues, two colleagues in chiropractic research, Mitch Haas and Mike Schneider. This was a 2010 in Chiropractic and Osteopathy paper illustrating risk difference and number needed to treat from a randomized controlled trial of spinal manipulation for cervicogenic headache. And they have a really nice, I can send you that link if you want, but they have a really nice description. They sort of just illustrate how you calculate it and what it means and for number needed to treat. And it's absolutely related to the risk difference. It's another way of talking about the risk difference. And so they would show you how to calculate it. I'll just tell you what it is. What it is, and this, we don't see this nearly as much in chiropractic and maybe for good reasons, but you see it a lot in drug studies. And what the NNT or the number needed to treat is the number of patients that you would need to treat to get one successful outcome, whatever that study design is. So if you're talking about pain intensity, the number of patients you would need to treat to get one responder to your chiropractic care. So, and again, it's a different way of talking about a risk difference. And so if your NNT is 2, well, that's pretty good. You only have to treat 2 patients to get one that has a success, right?
Right.
But if your NNT is 100, then you need to treat 100 patients to get one success. Now, it's going to depend a lot on what kind of intervention you're talking about, right? Because maybe it's a drug trial and it's a condition where death is imminent, and the drug's really expensive. So there's all kinds of things that go into that, how you interpret that number. I think what I've been seeing more often now, really, as we look at safety of interventions, including chiropractic, there's several investigators looking at safety-related things to spinal manipulation and adjustments for patients. And so similar to the number needed to treat, you can also calculate the number needed to harm. And that's a good way to talk about safety, because if you're having whatever your harm is, it might be just it might be a bad. I mean, we certainly have some in the media in chiropractic right now. If it's a dissection, and that's the harm. And you'd want that number to be really, really large. It is pretty large from the research I've seen, but you would want it to be very large. If you have a real small number needed to harm, then that says, you're harming 1 out of 2 or 1 out of 3 participants. That probably, or 1 in every 3 participants, that would not be very good. So, the smaller the number needed to treat, probably in general, the better. The bigger the number needed to harm is better. And if your readers or your listeners really want to kind of dig into this a little more, this paper I just mentioned, Mitch Hassan and Mike Schneider, it illustrates all of these things I've just talked about really well. And they also talk about risk differences and odds ratios in here. So, and they're doing it in illustrative. They're using one of Mitch Haas's data sets from one of his clinical trials on cervicogenic headache, but they're actually stepping through and showing you how to think about and how these these numbers are put there. So it's a great paper to have as something to I guess read on a Sunday morning with your cup of coffee if you're interested in learning more about these measures.
Yeah, that's terrific. I'll go ahead and post that to the website for sure. Yeah, it sounds terrific. Right. I can't wait to read it too. Can we talk about clinical significance?
Yes, absolutely, because clinical significance is awfully important, right? If you're not thinking about clinical significance, and I actually like to call this clinical importance rather than clinical significance. We see significant, that term in general is really jargon. It is jargon, but it's pervasive in the work that we do, or the articles that we read, or and so we kind of have to get comfortable with it. But I try to because we're going to talk about statistical significance, where significance is the word that is used. It still is sort of jargonized, but clinical importance is what clinical significance is. And this is determined not by the statistician. This is a conversation I have with my students and my colleagues on a regular basis, because, they'll come talking to me and I'll say, I can't really help you with clinical significance, because that's how much change, depending on your study design again. But if we're doing a randomized controlled trial, first you need to think how much change in whatever your outcome measure is important to the patient clinically. So if it's pain intensity on a 0 to 10 scale, which we often use those numerical rating scales, then how much pain is important. And then the second question is, how much more relief from pain would you need in the experimental group, or the group that has usual medical care plus chiropractic care, relative to your control usual medical care group? Both of those have to be answered in clinical significance. So a lot of the outcome measures that we use in our pain-related research are pain intensity, pain disability, and we usually try to kind of hit these for our primary outcomes. We always need to ask this question, but we should be asking about all of our outcome measures. And so I can't help you with that, except for I can go to the literature, and you will see a whole host of literature on both important clinical change, meaning, what do you want to see in your individual patient to say, okay, in a given measure, in those pain and disability type measures, especially in chronic pain patients, how much of a change do you want to see in that, as well as the important clinical difference between groups, or the important, how much more do you need to see in one group than the other to say that's clinically important. That's important. We need to start making some of these changes in our practice. So clinical importance is always important. Is needs to be considered in every clinical study. And usually you'll go to the literature. Now, it may be an outcome measure that doesn't have a lot of literature on it. And then, in that first pilot study that you might be reading about that someone used, they would be using their clinical knowledge to try to benchmark that and say, well, what do we think based on our observations and why we're using this measure? What do we think would be clinically important? But then usually literature will come out as that measure gets used in the literature more, in clinical studies more. Does that make sense?
Yeah, absolutely. And I really like you talking about measures that haven't gone through this scrutiny, just to know, how it might be calculated or determined. It always seemed a little bit of a mystery to me until probably a few years ago. But I've seen some interesting studies where they would maybe take a measure, and then if it's something that the patient is perceptible with, like pain or something like that, maybe they ask them a questionnaire, would you rate this as being improved or something like that? And so they could correlate those.
Right. And actually, we use those they're often called global measures of perceived measure of change.
Yes, exactly.
Starting.
Yes.
And we use those a lot too. And, there is not as much literature out on what would be important, but it's certainly, we often do diagrams of that because it really kind of gets the point across if you have big differences in your groups.
For sure. Well, let's talk about statistical significance. This is the significance that most people talk about.
This is where you're going to want to talk to your statistician. This is definitely where you can get help from a statistician, or that hopefully the statistician has helped write the article so that it's clear. But sometimes you have to use pretty sophisticated statistical methods. And we were just working on an article or a manuscript revision right now where it's a really hard measure that we used on something, and trying to make that easily interpretable by the reader is always what we're trying to do as good scientific writers. But it's not always easy. I tell you, I struggled with that all week. So statistical significance is typically, significance is the word used. I will say that the scientific community is very comfortable with that word, significance. The statistics community, we'd like to find some better words because it's bantered around. And I will say that this isn't always going to be in research articles, but if you see the word significance in the results section, it should be talking about the statistical significance. If you see the word significance in the last section, the discussion or conclusion section, usually it's clinical significance. Or you would hope they would say we're talking about statistical significance, because you have to consider both of them. So statistical significance is what we do to try to make inference about that target population with our sample data. And so this will take into account not just the effect size, but it will take into account the standard deviation or whatever other measure of variability. Every one of these clinical statistics I've talked about has a measure of variability, as well as the sample size. Okay, and so statistical significance asks the question, if we were to do this study over and over and over and over again, am I likely to get the same result, or is this just sort of a fluke? And so statistical significance, you would typically, we'll talk about p-values in a little bit. You will see confidence intervals and p-values are going to be the things that are reported relative to statistical significance. And it's all, if there is inferential statistics being done, then you're going to see terms about significance or statistical significance, and if that's in the results section, you usually assume that that's statistical significance that it's talking about. Now, it's really important to know that you have to take into account both clinical significance and statistical significance when you're weighing the validity of an article, or whether that article is going to have any impact on your practice, or if you're just going to sort of dismiss it as not. So we have 4 situations, right? We have situations which most people hope for, that you have a finding, you're between group difference, or you're between group risk, or your risk ratios are between your control group, like the usual medical care, and your group of real interest, like usual medical care plus chiropractic care. That you're hoping that that you have both your findings have both clinical significance, and that to get clinical significance, again, we look at the effect size, and statistical significance that takes into account the variability in the measure and the sample size. That is what most people are hoping for, right, when they do a study. Mm-hmm. You don't know until you analyze the data, right? You do a really sound study and you analyze the data, and you have to go in understanding you're in equipoise, meaning you don't really know what the answer is. And of course, you wouldn't be doing the study if you weren't really interested and pretty sure. Most people are pretty I know that chiropractic care, is going to really aid those patients, but you don't know until you see the data. And so that's what most people hope. But we have 3 other scenarios. There is a scenario where neither clinical significance nor statistical significance, you don't have either of those. You don't have clinical important effect sizes, and your comparison of groups on whatever clinical statistics you're using are not. They're definitely not statistically significant. We'll talk a little bit about more about exactly what that means in a moment. Well, that's a situation where, it's not a negative study. I always hear people saying it's a negative study. All studies give information and help us make decisions about patient care. It might be negative to you because you really thought that group of chiropractic care was going to do measurably better on your clinical statistics and clinical importance. That's been your observation and practice, and you're just sure that that's going to come out. But you know what? If you've done a sound study and you don't have clinical important effects and you don't have statistical significance, then that needs to be reported. We can't have publication bias where people say, oh, well, I'm not going to publish that because I don't want that to be out there. It needs to be out there. That's why you do the study, right?
Right.
And so maybe whatever treatment you're doing, chiropractic care is a big box, right? Maybe whatever treatment that you're necessarily doing, but you need to know, maybe that's not the most effective. Maybe there are other tools I have in my toolbox as a chiropractor. Maybe it's exercise, maybe it's recommendations in how you sit, or just all of those different things that you have, or maybe with that kind of patient, whatever it might be, that's not the best approach, and those need to be in the literature as well. So even though you might be sad personally if you're the PI of the study, it is important to publish that. And as a reader, you have to say, well, you ask the same question as you do if it was what we call what I don't call, but what I hear people call a positive result, where you have both clinical and statistical significance. And you just have to look, is it a good study? Assess the validity of the study, always sort of using our evidence-based clinical practice terminology. Is it a valid study? Did they do the things they were supposed to do? And if so, then the results are sound, right? There are 2 other situations that I think we need to talk about that could happen. And I would say early, not nearly as much now, but when I first came into the profession and I looked at, most of those studies were in JMPT, right?
Right.
And they were little tiny clinical trials, and maybe weren't due to. It was a research was pretty young in chiropractic, and there wasn't a lot of support, and so there were a lot of small clinical trials, and this is what a lot of them said: we have clinically important changes, but they're not statistically significant. Well, what that typically means is it could mean that they didn't have a big enough sample size. Could mean that the study was not done very carefully, so they had a lot of noise. They, a lot of variability that they could have potentially eliminated by a better design or better conduct of the study. Or it could just mean that, well, if we did this right and we did a bigger study, we wouldn't find clinical importance or statistical significance. And you don't know. But I saw in a lot of the early literature, well, we have a clinically important finding, even though it's not statistically significant. That's because we have too small a sample size. So we're going to call this a win. Well, that's not really right. It might beg that we need to now try to do a large study with a big enough sample size to see if we still see this clinical importance and that it is statistical significance, because you don't know. The other situation that we don't see nearly as much in chiropractic, but you definitely see this, and this is where you have very, very large sample sizes. So often if you see, and we do see some of this work in chiropractic, you'll see some of the national databases will be looking at specific chiropractic questions, and there'll be thousands and thousands, maybe more than that, patients or participants in the study, or respondents if it's a survey, and almost anything looks statistically significant because you have such a huge sample size. But the clinical relevance or the policy relevance or whatever clinical importance is minimal. And so you'll see statistical significance, but does it really mean anything? And so typically you don't have to ask that question unless it's a really large sample size. And then you have to scrutinize and make sure, well, okay, yeah, everything looks statistically significant, but so what, right?
Right.
They're really small differences in groups or in changes or whatever it is that you're measuring.
Well, great discussion. How about let's follow up on the statistical significance and talk about p-values and confidence intervals?
Okay, so I think, let's see. I think I will start with p-values because I prefer confidence intervals. So I will talk about p-values and then how we can back into confidence intervals, in particular in clinical research. So a p-value, often people describe a p-value as the chance. I had some of my notes from my basic classes here just so I don't, confuse anyone. They'll just say that it's the chance that or the probability that what you see is by chance, and that's really not right. I know it's a simple explanation, but what it really is, it's a conditional chance, and what it says is that if the null hypothesis is true, and so for the kinds of measures we were talking about earlier, it's if the two means are the same in the two groups, or if the odds ratios are 1, or the any of the risk ratios are 1, or any of the differences are 0. That's going to be your null hypothesis, and then you're trying to disprove the null hypothesis in classical statistics. So if that's really true, then what is the chance that I get the value that I observed or larger? Okay, so that's what a p-value is. And so you're looking for very small p-values. You want that chance to be very small if you're going to say, yeah, I think that this is a real effect and not sort of just due to chance. And in the literature, you will typically see people use values, p-values, they'll set them at 0.05. Now let me tell you, 0.05 is not a magical number. That means you have a 5% chance that what you observed you have a 5% chance that what you observed in your sample, if the null hypothesis is true, is really not the case. So you might make a decision error. Okay, so p-values are about making decision errors. And you want that chance to be as small as possible, but 0.05 is not magic. So in every paper you look at, you do not want people saying significant, not significant, at a 0.05 level. You want them to give you the p-value. And let me also mention that p-values aren't necessarily too precise. So if you see p-values that have like 5.0000001, that is not more significant, statistically significant than less than 0.001 in which it should be reported. I think we often see that, in particular in talks. I think by the time it gets to a paper, hopefully it's had peer review to the point where you're reporting them appropriately. So you want to see them give you the p-value. And let me say that 0.04 is not different than 0.06, really. One, you call a statistical significance. One, you don't. But by actually giving, if you're testing at an 0.05 level, which is typically what we see, if the reader gets to see the p-value and kind of read the study, they can make their own decision. Now, the researcher, if they say, I'm testing at an 0.05 level of significance, and I got a p-value of 0.04, so I'm going to say that's a statistically significant result, hopefully it's clinically important too, because otherwise we don't care, right? Then that's okay, but it allows the reader to make their own decision. If we have a p-value of 0.45, let's say, that doesn't appear to be very likely that there's a difference between groups, or that the risks are different depending on what it is that we're measuring for our outcomes. And then you can kind of hang it up and say, yeah, that's probably not very likely. But all of those p-values, like from 0.01 to 0.10 or 0.20, well, it kind of depends on the study and other things. And so you definitely want to see, hopefully you're not reading many papers anymore, because if you're reading psychology and sociology, it's still prevalent that they'll just do a little star and say, p less than 0.05, but that's not best practices, and that's not going to be helpful for you as a clinician out there to be able to really make your own determination of whether that's an important effect or not. Now, we could also talk about, there are things like alphas and such like that. I mean, I don't even talk about those, because unless you're really a statistician or really doing some of the heavy-duty statistical lifting, you don't need to really know those terms. Usually you'll see in the statistical methods section, you'll see something about we are going, and this should always be said a priori, meaning before you ever analyze the data, let alone write the paper. So this should be stated in your research protocol. If you are writing a grant proposal, it should be stated there that we are going to set our level of significance at p point equals or at 0.05 or 0.01 or 0.1, and then there could, if it's not 0.05, I mean, I would say you need to justify it, because people are going to expect 0.5. So if, let's say you have, like we have a paper right now, that our study where we had two primary outcome measures. One was pain disability and one was pain intensity. And we wanted to make sure that we made a call on statistical significance that would be reasonable. And so we said, well, we have two, because if you test and test and test and test and test every variable you have, you're probably going to find by chance that one is significant at the 0.05 level or whatever level you set. But we actually tested at 0.05 divided by 2 at 0.025. So we had to have a little bit more evidence to say it was statistically significant, and we put that in the grant proposal, and we put that in the paper, and that you always report that, and that will be in the statistical methods section. And then you would expect that when people are reporting their results, they give you the p-values, and then you can say, wait a minute, they said that was significant, but they're not using the level of significance they stated in their method. I hope, at least in the top tier clinical journals, you're not going to see that. I mean, occasionally a mistake comes because they have rigorous peer review, and hopefully in most of the chiropractic-related journals we won't see that either. Confidence intervals are really much more, in clinical journals, you have to use confidence intervals, and in the top tier, they may ask you not to use p-values at all. Some people like to do both. P-values and confidence intervals, for the most part, will give you the same information in a different way. They go back and forth, and they should be completely consistent with each other. So confidence interval, and it is, the effect size will be somewhere, or the clinical statistics, summary statistics will be somewhere in the middle, usually in the middle of the confidence interval, but it will be in the confidence interval. And a confidence interval is something that it captures the uncertainty or that variability in sample size again. And often I hear it described, and I think this is the nicest way, is an interval of plausible estimates. So it gives you a sense of, if you have a lot of variability, it'll be a really wide confidence interval. If you have not much variability and big sample size, it'll be a narrow confidence interval. So it talks about how certain, the certainty and the precision of the estimate of your clinical effect. And the nice thing about confidence intervals is rather than just being a p-value, which it just says, people like to hone in on the p-value, it's 0.04, yay, I'm statistically significant, or it's 0.45, it's not. What the confidence interval does is it gives you an effect size for your clinical statistic. That's what it reports first. That's called a point estimate. And then it gives you an interval estimate. And of plausible, usually you'll see 95%. That's similar to 5%. For a p-value, you'll usually see 95%. Sometimes you'll see 90% or 99%. That should be talked about in the methods. But the 95% confidence interval, you can look at if you're looking at differences, you can look at the confidence interval. First of all, it gives you three things. It gives you the estimate, it gives you the direction of the effect, and it gives you the measure of certainty, or the narrowness or width. And it gives that very, very quickly. So that's why it's really easy to look at, and I think it's much more relevant to thinking a clinician looking at. And so if you're looking at some of those measures and you want to get a sense of statistical significance and you have a 95% confidence interval, you can say, if you're doing mean pain intensity between the usual medical care group and the usual medical care plus chiropractic group, and you're saying how much did they improve on pain intensity in these two groups? Well, if 0 is in your confidence interval, then you would not have a statistically significant result at 0.05. If 0 is outside of those estimates, the plausible estimates, then it's not very consistent with the null hypothesis, and you do have a statistically significant result at an 0.05 level of significance, or p-value of 0.05. Similarly with risk ratios, remember 1 is the important number to think about of being no difference. And so if you have a risk ratio that you're seeing reported, then you would look for, is 1 inside that confidence interval? And inside the confidence interval means it's consistent with the null hypothesis that there's no difference. And so there would be no statistically significant difference at an 0.05 level if you're looking at a 95% confidence interval. And similarly, if you see 1 outside of that interval, then there would be a statistically significant result. So you can always get at some sort of statistical significance by looking at a confidence interval, but what you also get is you get the direction of the effect, the magnitude of the effect, how big is it, what direction, which group is it in favor of, and then you get some measure of precision or certainty in that confidence interval. So there's a lot more to be had, and you can still ask questions about statistical significance, or if the authors are talking about their statistically significant results, you can say, oh, I got to look at that. Is 1 in that interval or not? Okay, yep, that looks right. What they're saying looks right. So I would always, they go hand in hand, but I would always recommend that people working on research if they probably don't even need to put p-values, but they need to at least put confidence intervals. I will tell you that the top-tier journals will want confidence intervals, and often they won't want p-values at all because they just feel like people don't look at the actual measures enough. The confidence interval can also tell you about clinical significance or clinical importance because you have that effect size or that point estimate first before you have the interval of plausible estimates. So, I think we see a lot more confidence intervals than we used to in the chiropractic literature, and that is the standard for clinical studies. And really, I would say a lot of my basic science colleagues, whom that didn't used to be the standard, I convinced them, and then their journals convinced them that they should be giving confidence intervals also. And so that's a nice. There's still a lot of basic science journals that only give you p-values, but you see a lot of confidence intervals out there now, which is nice.
Great. Yeah, thanks for the explanation. That was really good. I appreciate the background as well and the relevance to chiropractic profession. How about power? How does that play in?
Yeah, power. So power is linked with sample size calculation and sample size. And I think a lot of people don't realize that. They think there's something. Sometimes you'll see in a paper, you'll see, we did power analysis, and this is how we determined that this was the number of participants we needed in our study or in each group. And sometimes you'll say sample size calculation. And sometimes then they'll say, well, we did power analysis. But they're interchangeable terms because you use the same things. You use usually some power analysis to get at your sample size calculations. But you can just think of that as, it's how they calculated how many participants they needed in their study. And let me tell you, this is the one I have some note sets here because this is the one I always say when anybody asks me, in particular my students. I say there's no magic involved because this is the one. It seems so even some really good scientists will sometimes just sort of, I think, lose it for a day, and they'll walk in and they'll say, I'm working on this study, and I really need. Can you calculate a sample size for me? To me, their biostatistician, and what you hope if you're in this situation where you're actually doing the research and you're asking someone, you should expect about 5 questions, because I need all kinds of information. I have the tools to put some numbers in to try to help you with that, but you have to come up with a bunch of things. Number one is we need to know what you typically do power analysis and sample size calculations around 1 or 2 primary outcome or primary response variables, the ones that you're really hanging your hat on. And typically for us in our pain-related research, that's typically pain intensity and pain disability. Sometimes now there's a new measure, pain interference. How much does pain interfere with your daily activities? We're starting to use that a little bit. But that's the PI has to choose that. That's the investigative team needs to decide what is the most important variable. And that's what we're going to calculate our sample size around. You need to determine what the most important comparisons are. If it's a 2-group clinical trial, then you're going to look at the differences in that outcome measure between groups after probably a course of care and intervention or something. But if you have, let's say you have 4 groups, you have different combinations of therapies, well, certainly that's something as a statistician I can give you some advice, but it may be that you don't want to just look at all possible differences because that might need a really big sample size. Maybe you have you have a control and then you have some different interventions, and really your primary comparison of interest is each of the different interventions with the control. That's only 3 comparisons. If you did all pairwise comparisons, you'd have 8 comparisons. So that's something that the investigative team needs to think about. And I know that a lot of people listening to this are clinicians. They're not doing the research, but this is what you need to be looking for in your statistical methods section of the paper, because the author should be telling you how they came up with all of this. Obviously, when we do inferential statistics, so sample size calculations do not need to happen if you're only going to describe your sample. But when we do studies, we typically want to make inference. And so you have to have some idea about what the variability of your chosen outcome measure is. For the ones I've been talking about, there's quite a bit of literature out there. Pain, pain intensity, pain-related disability, and now pain interference is pretty new, but it does have some literature out there now too. And so you can go to those prior publications and look for publications, or the author should look for publications, or should have, that report it in similar patient populations. So if you're looking at chronic low back pain, that's where you should be looking at it and see, okay, what kind of variability did they find? Are they in a ambulatory setting like we are? Okay, then that's, that might be a good variability to say we feel like the variability of the measure is going to be around here. If you don't, and this, I think we talked about this a little bit before, Dean, if we don't have really any idea about outcome measure, that's when you need to do a pilot study or a feasibility study. I will say that if it's a pilot study or a feasibility study, you don't do a power analysis. You still have to talk about how you came up with your sample size, right? You're putting patients at risk in a research study, and you always look at the risk-benefit ratio. But if it's a pilot study, you're probably going to say, well, we felt like we needed 10 in each group to really be able to test all of our methods and to get some estimate, some sort of effect size, some estimate of effect, and some estimate of variability. And then in the next study, where you do a formal sample size calculation with power analysis, you would then use your estimate of variability to calculate the necessary sample size. The other thing we've talked a little bit about before is that you need to know what the clinically important effect, and this is what I would call clinical importance, right? What is the clinical important effect that you want to detect between the two groups for your data analysis? And sometimes this is called the effect size. I already talked about effect size before, which is a little different meaning of effect size. So it's really, sometimes it's called a minimal clinical important difference, or MCID, if you've ever seen that in the literature, minimal clinical important difference. And that says, how much better does that one group need to be on on your primary outcome measure than the control group for you to say, okay, that's a clinical important effect. So you actually do sample size calculations around that clinical importance that you've already determined. And then you have to decide what's your level of significance and power. So the level of significance, I'm going to come down to tell you exactly what power is in a minute, but the level of significance, if it's 0.05, that's fine. If it's 0.025, that's fine, but you have to use what you're going to use in your study. If it's 0.1, that's fine, but you have to use that in your study. And power specifically is, and we often see this as 80% or 85% or 90%, the bigger the better, is the chance that if there really is a difference out there, we don't know what the target population, we don't know what the truth is. We're taking a sample from that, and we're just going to say, okay, we want the best chance we can get. And usually the bottom line there is 80%. We want at least 80% chance that if there's an effect out there, we can detect it with our statistical analyses. So sometimes you'll see that at 80, sometimes you'll see it at 85, sometimes you'll see it at 90. Obviously, you can't have it at 100 because you don't know that you're always going. There's got to be some uncertainty there, and you'd have to have thousands and thousands and thousands of patients if you were getting up towards 100%. But that's what power is specifically, but power in general is part of the sample size calculation. So when someone comes in and talks to me, they come in and I say, well, I need a whole bunch of information from you. And then I would be happy to either me or my associate, who's also a biostatistician, that we can use the statistical software we have. And actually there's a bunch of good web software out there. Russ Lenth, Lenth, has just a nice little package out there. He's a statistician at the University of Iowa, really nice guy, some great little commentary that goes along with it. That for sort of the standard statistical tests, I have my students use this because they need to learn how to do this on their own. And but you have to know all of these things before you go in and use the software. These are the questions you have to ask. And otherwise, if we're obviously for grants, you don't just sort of choose one thing and say, this is my sample size. You usually look over a lot because you might put in all of your information and you need a sample size of 500 in both groups, and you don't have the funds, you don't have the time to do that kind of study. And you say, well, what if I move this around a little? What if we look for a little bigger effect size? What if I go over different variability and we really tighten up and can tighten up that variability? What if we do 0.10 for my significance level of testing, or we were doing 95% power, but now we'll go down to 80%. And then you'll look at, because you need to get numbers that you can actually realize, right?
Right.
And so so typically, and often you'll hear people call, we don't have room in publications or grant submissions anymore to put power curves, but that's what I usually do for my colleagues and it would be a curve, and they can look at all the kind of constraints and sort of say, this seems reasonable. But then that has to be reported in the article. So as readers, you need to say, and if they're doing inferential statistics, okay, there needs to be a formal sample size calculation or power analysis. Otherwise, it doesn't make any sense. One other thing that I will mention about power and sample size calculations is there's no such thing as post hoc power, meaning the power is calculated prior to initiating the study and collecting any data. And I still see people come. I mean, I even had a reviewer come back saying, well, you didn't say anything about your post hoc power. It doesn't make any sense once you've collected the data. It's something that you're doing in anticipation of doing a sound study with a big enough sample size that you will be able to detect the differences that you think are clinically important, but not any bigger than that, because you don't want to, every research study has inherent risk, and we look at the risk-benefit ratio. So you don't want to be bringing 200 people into your study if 100 is sufficient to get a clinical significant result.
Right. Yep.
One other thing I'll mention about power is, and you didn't put this on your little list for me, but this we see a lot. We see that we have small, medium, or large chance of getting effect or something like that, right? Small, medium, large, and none of the specifics I just talked about. Nothing about the primary variable or the important comparison or any estimate of variability or the effect size. And they say this is based on Cohen probably 79 or something like that. And it's just ridiculous, because there's none of these things that are important about sample size calculation, and you would get the same sample size calculation each time for a small, medium, or large. Russ Lentz has a nice little thing. He calls them, it doesn't help to have a T-shirt size when you're trying to calculate sample size. I think that's sort of nice. And it's sort of that situation that you brought up a little earlier, Dean, where you said, well, what if there's no information about what the clinically important effect is? And I think that's usually when we come into this small, medium, or large, because no one knows.
Right.
And I guess what I say is then you shouldn't be doing a formal test. You should be doing a pilot study and get some information.
Yep.
It makes no sense.
For sure. Well, as we start to wrap up here, I did want to ask one last question, and that is something that I hear quite frequently, and I see on Facebook and social media, in the media, all over, and that is a misinterpretation, I guess I'd call it, regarding correlation versus causation. Can you speak to that just for a minute or two? Yeah,
definitely. So, and this is a hard thing. It really is association versus causality. And when we do a clinical trial, for instance, it's always a study that's going... Is that what you asked me?
Yeah. Yep.
Am I on the right?
Yeah, association versus causation.
There was something else on my piece of paper here. I just wanted to make sure I was answering the right question. When you're going forward in a clinical trial, for instance, you know what the patients look like at baseline, and then you follow them, and you try to take out anything that could be happening to them other than the different treatments, and so that you can attribute all their improvement or typically in chiropractic we're looking for improvement in pain or whatever to the treatment itself, so that the treatment caused that. And that and so in a clinical trial you can interpret your results as causality. However, we have a lot of different study designs, and in particular we see a lot of cross-sectional surveys. A survey is cross-sectional. You just get everybody at one slice in time. And we can still analyze that data sort of to generate hypotheses that we think might be happening. So, we see if people had gone to chiropractors. We've got quite a few surveys going on here. The Gallup has been doing some. So we see if respondents to the survey say that they saw a chiropractor in the last year, and then you ask them about back pain, and have they had back pain in the past year, and you can say, is there an association between those that had back pain and those who saw a chiropractor, right? But we don't know. They may have seen a chiropractor long before they had back pain, or vice versa. There's no causality necessarily there. You would need to use that then to ask some research questions that you would need to look at something like a clinical trial or a cohort, say something that was a prospective study where you were bringing in your participants and then following them over time, and then you could say causality. And in particular, there are other kinds of studies. We don't see these as much in chiropractic, but certainly in any hospital-based or any kind of rare conditions, you can see articles that they get participants that have a certain outcome or a certain disease, and then they look back at their history and to try to get a sense, because it's really hard to do something prospective if you have a rare condition, or maybe it's just, well, we think there might be something going on, but let's use this EHR data we have to kind of take a look to see if there's an association, because if you're looking backwards, you can't prove causality. You don't know when things happened relative to one another. You can only know that if you're looking at a prospective study where you know everything about the participants relative to what you're studying, and then you move forward. That's the only place that you can say causality. And we see a lot of those words bantered around sort of interchangeably, I think, is what you're saying.
Yeah, absolutely.
And I see that, but we have to be very careful. You can only look at causality in prospective studies. Everything else is just association. Might be really interesting, but you would have to test it in a prospective study to really be able to say, okay, this is the way I think it is.
Perfect. Well, I'd like to end today's talk with a question, and that's the question I always ask everybody right at the end, and that is, could you offer any advice to aspiring students or chiropractors who might wish to become scientists or researchers?
Well, we need more than you could imagine.
Absolutely.
It would be great to have a lot more clinicians involved in some way in the research or to become research. Now, at the same time, I'll say that it's not an easy path. I mean, you know that, Dean, right? You have a PhD.
Yep.
And you don't necessarily have to have a PhD, but you have to have training, and you have to have adequate, good training. You need to. And so that probably means it's difficult. I don't know if were you practicing when you did your PhD?
I still am. I've never left practice.
Okay. So there's only so many hours in a day, right? You may need to do it a little slower, or you may not have much time on the offsite. And the other thing I think that, we do, people who do research do not do it for the money. You can make a lot more money in clinical practice than you can as an academician or a researcher. But so people need to ask themselves what their motivations are. But if it's to answer questions, and I guess the thing that I can say, and I think you can probably say this too, Dean, in your environment, is that I come today, every day I come, there's some intellectually stimulating discussion happening. It's always asking questions and looking at papers and working on research studies, and never is there a dull day. And it's exciting you feel like you make a difference, right? Everybody has to ask for themselves. What I will say is we've been trying to train the next generation, and we have about 35 graduates from our very small graduate program, Masters in Clinical Research, and a chunk of those are either continuing their research education and mentorship, and are early researchers, and some of those work in the research arena. Quite a few of them do, but don't ask the questions. But I think they still find a lot of they feel good about that. It's exciting, again, to be in that environment. Many of them are in academic settings where maybe they have taken their clinical research tools that they learned and sort of turned them sideways and are doing educational research. So that's very exciting. They're still doing research. And even some of them go back into private practice, but every single student I've seen that's gone, that I see when they come back for homecoming or something, they'll say, I'm such a better thinker now. I think critically so much better. I have a set of skills that I couldn't imagine having practiced without. Of course, you don't know what you have until you get it, right?
For sure.
I think there are just wonderful opportunities for researchers. So if people are saying, this is not enough for me, just full-time practice, and that's what a lot of our prior students were. They loved everything about it, but just full-time practice wasn't enough for them. And they were able to say, okay, this is going to be a different monetary benefit, and I'm going to have to put the time in because it does take time. But I think every single one, certainly that we employ quite a few of them at the research center. Of course, we like to keep our best students here if we can, especially if they want to just sort of be. We want to keep them around, and I think every day they are saying this was the right move to me. I'm so glad because it's only recently that I think people in chiropractic programs know that research is one potential career path. It was always you're a clinician, you're an educator, or there's nothing else, right? And
right.
I will definitely say research is a career path, and certainly if people are interested, give me a call. Give Christine Gertz a call. Give other chiropractic researchers a call about what it would take. And we have people that didn't actually. Don Murphy's a perfect example. He's a busy clinician, but he has continued to do things in his practice that have been super relevant. That's sort of. Not many people can do all of that, but certainly Dawn has done a great job of that. So there are a lot of, I think, avenues. Start asking questions right away, but we need so many more. So I would love to hear from some of your listeners about what they're interested in and whether they should potentially think about a career. Maybe it's a complete career change, or maybe it's just a shift in. And such. And then there are some, not many in chiropractic, but practice-based research networks out there that they could be involved in research in terms of getting patient data and all of that, but not have to actually do the research. So I think there's just a wealth of opportunity, but we need research scientists because I think when we started our program in clinical research, we got a grant to do that from NIH. And what we said then and what I think we still believe is that the best people to answer questions about the efficacy, the effectiveness, and the safety of chiropractic are chiropractors, right?
Absolutely.
PTs are doing all your research, and PTs do a lot of manipulation research. They may have a completely different thing in mind, and so I certainly believe that. I will always believe that.
For sure. Well, I've really enjoyed our discussion today, and I appreciate you coming on to the Chiropractic Science Podcast.
Yeah, well, thank you so much for having me, and I'll look forward to hearing more of your podcast because I see a lot of interesting ones on there.
Great. Thank you so much.
Thanks so much.
Thanks again for listening to this great interview with Dr. Cindy Long. I hope you now have a greater appreciation for the role of statistics in chiropractic research. Stay tuned for more episodes. If you have suggestions or comments about the show, please let me know. Bye for now.